Thank you. Good afternoon. My name is Estevao, and I study scientific networks, especially the hierarchy into these networks. So about me, I'm from Minas Gerais, state of Brazil, Brazilian cheese bread or pão de queijo. I have a bachelor degree in social communication in University of São Paulo, and now I'm studying complex system at University of São Paulo, and I study a little bit of um, data science. My my advisor are from data science, and I'm studying academic mobility through big data manipulation. About this work, uh, we have empirical networks that are described since the 2000 years. Newman, for example, bring us the empirical networks of collaboration in mathematics, citation, World Wide Web, Internet, power degree, and protein interactions. All, all of them appear to have a power degree law, but in specifically in innovation networks, we have some issues. If we observe in some nodes are eventually more central for links than the others. And many degrees have triangular relationship. Although some nodes participate in this relation are far more than others. And sometimes the networks have different degree distribution from per Barbas Albert model. Then now we have some models that have been proposed to explain those characteristics. Specifically in scientific collaboration, we have networks being studied since the 60s, and Wagner and Leydorf argued that the peripheral nations can emulate organization structures from the central countries, making it different. So we ask about how the structure of scientific collaboration networks differ between the peripheral nations or institutions from the others. We in this work we focus on the most collaborative fields of knowledge, which are physics, medicine, and engineering and computing. In our methodology, we use OpenAlex that are a free accessible knowledge graph that includes more than 250 million scholarly works. It's open available, and the full data is available to cloud computing. You can find bibliographic data like citations, research field score, publication year, author affiliation, and Zambigration Institute aggregate data like the country of the institution, coordinates. Okay, we get these works from OpenAlex by the field score, and we gather works after the 90s. We select the institutions that have more than 10 works, and we aggregate the data between the decades. We rank the work from percentile. We have the largest institutions has more than 10 more than 10 percentile in the data, and the others are considered small institutions. Then we made it the indirect graph and the institutions collaboration networks with and compare the total situation, the large institutions, and only the small institutions. Then we get these results. Comparing the degree distribution of this distribution, we have a little difference between large institutions than small institutions. And the small institutions have a degree distribution closely to the curve of the total degree, the total network. Here we have the country of each network, the institutions. In medicine, we have the similar results. In January, we have a little different behavior in this network, especially in the large institutions comparing to the small institutions and computational. So we, considering the most productive institutions, we think the model Barbash-Alberts is not sufficient to describe the large number of collaboration, and maybe the Watson Struggles model could could describe it more. And the difference between January and the other fields is very visible. In future works, we could try to analyze the slope of each empirical network and try to apply hypergraphs to scientific collaboration between the institutions, and we could compare the Handel networks such as Barbash model, Watt-Struggles, and Edel-Reni, comparing to the empirical ones. That's it. Thank you a lot.
Thank you. Thank you very much. We have a ton of time for questions. We have a lot of time for questions. So everybody's going to ask one question. Maybe I should select people randomly, or I will just allow you to decide if you want to ask something. Who is going to start in this round? Albert. Yeah.
What is your background? Did you do physics or social communication? What is your main goal?
My main goal is to understand social physics.
Social physics.
Yes, I really like it.
So you qualify for a Nobel Prize then?
Second, I have a question. Social networks have a specific characteristic with respect to any other network, in the sense they are assortative. And they have positive correlation, degree correlation. Now you are using a list of reference model which have no correlation at all. That is, they are constructed without correlation. In particular, the Barabasi-Albert model normally tends to be disassortative because tends to have these hubs which are connected to lower. So what you see there, the discrepancies that you see for the larger institution, the rich club, if you want to call it in this sense, it may be that are due to the fact that you have to include in your model explicitly degree correlation stuff. Right. Because it may be well be that larger institutions are more correlated, they participate in larger projects, in national projects, together. So probably if you take, there are many models that include correlation, and this is, I don't know, a suggestion if you want.
Yeah, that's a good one actually. Any other questions? We have time if you have questions, but don't be shy. No? Okay. Then let's thank our speaker once more. And let me welcome the last speaker, but not least, of course, of this session and of the conference.